What if I told you that every single star you've ever seen in the night sky, every twinkle, every constellation, every distant glow, is just a drop in an ocean so vast your mind can't fully grasp it? Pause for a second. Really think about that. Because today, we're going to stretch your imagination to its absolute limit. How big is the universe really? Let's begin our journey not with galaxies or black holes, but with something familiar, Earth, our home. The third rock from the sun. If you could wrap a measuring tape around Earth's equator, you'd need about 40,000 kilometers of tape. That's the world we call vast. But now, look up. The moon, orbiting us at an average distance of 384,000 kilometers, is already 10 times farther than that measuring tape could go. Light from the moon takes just over a second to reach us. Simple, right? But now let's push out a little further. The sun, 150 million kilometers away. A beam of light from the sun takes about 8 minutes and 20 seconds to kiss Earth. If the sun were the size of a basketball, Earth would be a tiny peppercorn about 25 meters away. Still not too hard to imagine, but here's where your mind starts to melt. Let's leave our solar system. The nearest star system, Alpha Centauri, is 4.37 light-years away. That's not 4 years of driving, flying, or even rocketing. That's 4 years of light, the fastest thing in the universe, traveling 300,000 kilometers every second. At current spacecraft speeds, it would take over 75,000 years to reach it. That's how far we are from our closest stellar neighbor. And yet Alpha Centauri is still in our cosmic backyard. Now zoom out. We live in the Milky Way, a swirling galaxy made up of 100 to 400 billion stars, each potentially with its own set of planets. The Milky Way is about 100,000 light-years across. That means even light, moving faster than anything else in the universe, would take 100,000 years just to travel from one end to the other. And remember, this is just our galaxy. As we peer deeper into space using telescopes like Hubble and James Webb, we discover not hundreds, not thousands, but billions of galaxies. Current estimates suggest there may be over 2 trillion galaxies in the observable universe, each one containing billions or even trillions of stars. That's not just a big number. That's a scale beyond comprehension. Imagine every grain of sand on every beach on Earth. Now imagine that each grain is a galaxy. Even that doesn't do it justice. The observable universe stretches 93 billion light-years in diameter. How is that possible if the universe is only 13.8 billion years old? Great question. Because space itself is expanding faster than the speed of light. As light travels toward us from distant galaxies, the universe keeps stretching, pulling those galaxies farther away even as their ancient light races toward us. It's like trying to walk up an escalator going down that's accelerating. And what about the edge? Is there an edge to this unfathomable expanse? Not exactly. The observable universe refers to the portion of the universe from which light has had time to reach us since the Big Bang. Beyond that, there may be more universe, perhaps infinitely more, but it's hidden behind the curtain of time and space. In fact, scientists believe that the entire universe may be infinite, with no edge at all. And if that's true, then the part we can observe is just a tiny patch, like a single pixel on an infinite screen. Let that sink in. You, watching this video, are made of atoms forged in ancient stars. Your brain, your thoughts, are the product of particles that have traveled across cosmic distances over billions of years. And yet, we are just specks in a vast galactic city, inside a continent of galaxies, floating in a boundless ocean of space and time. Now let's blow your mind even further. Some scientists propose that our universe may not be alone. Enter the idea of the multiverse, the concept that our universe is just one of many, each with different laws of physics, different timelines, different versions of reality. If true, this means everything we see, everything we know, may just be a single bubble in a vast cosmic foam of infinite other universes. And we may never reach them. Why? Because even at light speed, most parts of the universe are receding from us faster than light due to the expansion of space. They are forever beyond our cosmic horizon. They exist, perhaps, but we can never reach them. It's like standing in a boat on the ocean and watching islands sink below the horizon, never to be seen again. But we know they're there, or at least we believe they are. And it gets weirder. Quantum mechanics suggests particles can exist in multiple states at once until observed. Combine that with the vastness of space, and you enter the realm of cosmic probability. Somewhere out there, there could be another Earth, another you. Not science fiction, a possibility based on the laws of physics. Because in an infinite universe, every arrangement of matter eventually repeats. That means, statistically, your exact life may be playing out somewhere else, maybe with small differences. Maybe you're an astronaut in that universe. Or you never watched this video. Or you're the one making it. But let's return to now. To you, to this moment. You are alive, conscious, on a tiny blue planet orbiting a yellow star in a galaxy among trillions. And still, we search. We build better telescopes. We launch probes. We ask bigger questions. Why? Because despite our smallness, the human mind has an unrelenting hunger to understand, to map the unseeable, to touch the infinite, and that is beautiful. So, how big is the universe really? It's big enough to humble your ego, big enough to stretch your imagination, big enough to remind you that life, in all its fragility, is a miracle floating in a cosmic sea. It's too big to fully understand, but just small enough for you to wonder. And that wonder is where science begins.